In Hello everyone, in this video we are going to study the practice set 3.1 all examples. So let's start from the first example. So here I have drawn the figure which is related with the practice set 3.1 first example. So this is the figure and based on this figure some questions are asked. So we will study these questions one by one. First question, here AC is a radius, CA is radius and AB is a tangent. Line AB is tangent. It is from the figure, and if it is radius and tangent, so what is the relation of a tangent and radius? By tangent theorem. Therefore, by tangent theorem, radius CA, it would be perpendicular to line AB, and therefore angle CAB would be 90 degree. Now we have to find out this distance of C from this tangent. It is nothing but the radius. So distance of C from line AB, it is nothing but R which is given radius, it is 6 cm. So distance is 6 cm. Third question, distance AB, this distance AB is given 6 cm. Radius we have 6 cm and we have to find out BC. So here we know by tangent theorem AC is perpendicular to AB. That means a triangle CAB will be right angle triangle, and if it is right angle triangle, so here we can use the Pythagoras theorem. So in triangle CAB, AC is perpendicular to AB. Reason tangent theorem. If it is perpendicular, so by Pythagoras theorem, hypotenuse square, that will BC square is equal to AC square plus AB square. AC square is nothing but it is given 6 cm radius plus AB is 6 cm, so 6 square. So it is 2 times into 6 square. So BC square. If you take the square root on both the sides, so we will get BC is equal to 2 square root is root 2 and this it would be 6. That means therefore BC's value is nothing but 6 root 2 centimeter. Fourth question, in this fourth question, we will take once again the triangle ACB. In this triangle, AC is perpendicular to AB. By tangent theorem, segment AC is equal to 6 cm. Segment AB is equal to 6 cm. Therefore, triangle ACB is isosceles right angle triangle. And if it is isosceles right angle triangle, then angle ABC means these two angles would be congruent, and that would be 45 degrees. So therefore angle ABC congruent with angle ACB, which is nothing but 45 degrees. Second question, figure is given. In this, MR and RN are the two tangents of tangent segments. OR it is given 10 cm, OM it is given 5 cm. And we have to find out what is the length of the tangent segment. Means MR's value and RN's value we have to find out. This is the first question related with this second example. So to find out this, so we'll consider this triangle. In triangle OMR, In this triangle OMR, OM is perpendicular to the MR. It is by tangent theorem. What the tangent theorem says? Tangent theorem says that the radius is always perpendicular to the tangent. So this is perpendicular by tangent theorem. Therefore, by Pythagoras theorem, we can use the Pythagoras theorem in this. Pythagoras theorem. By Pythagoras theorem, we can say that hypotenuse square, that means here if it is 90 degrees, so this would be the hypotenuse. OR is the hypotenuse. So I'll write directly formula. OR square is equal to, side 1 would be OM square plus side 2 would be MR square. If you put the values, OR is given 10, so it is 10 square is equal to OM's value we have 5 square plus MR we have to find out. I'll keep it as it is. Making squares, so 10 square would be 100 is equal to 5 square is 25 plus MR square. 25 transfer it on this side, so 100 minus 25 is equal to MR square. So here therefore MR square we will get answer 75. If you take the square root on both the sides, so we will get MR is equal to 75. If you find out the factors of it, 5 pairs of this, so 5 root 3, so centimeter. So MR would be 5 root 3 centimeter. If MR tangent segment, one of the tangent segment is 5 root 3, so other tangent segment is also 5 root 3. Therefore, MR is equal to NR is equal to 5 root 3. Reason, tangents drawn from external point or you can write equal tangent segment. If the tangents drawn from the external point, so those tangent segments would be congruent. In the second question, they asked you the value MRO. So here we will see because the angles measurements are not given, so here we are going to use the property of theorem of 30-60-90 or 45-45-90. So we'll find out what type of angle is this. So here by given MO, it is 5 centimeter, and for the second example, MO is equal to 5 centimeter, OR is equal to 10 centimeter. OR means it is a hypotenuse 10 centimeter. What is the relation of these two? If you observe it, MO is a half of OR. Means 5 centimeter is a half of 10 centimeter. Means this side is a half of the hypotenuse, and you know the property where the opposite side of a 30 degree is always half of the hypotenuse. Means this, therefore MO is side opposite to 30 degree. Therefore angle MRO is equal to 30 degree. Why? Because MRO angle is opposite to MO. So we have got the answer of angle MRO. Now we'll think about the MRN. MRN. If I want to find out MRN, so I should find the angle NRO also. Okay, so in this case, again I'll use the same concept. MO is 5 centimeter, so NO is also 5 centimeter. So MO is equal to NO, this is 5 centimeter. Again, NO is half of hypotenuse hypo OR. Therefore, NO is side opposite to 30 degree. So this is also side will become the opposite of 30 degree. So which is the angle 30 degree? NRO angle. Therefore angle NRO is equal to 30 degree. To get the answer of MRN, angle MRN, it is nothing but sum of these two angles, angle MRO plus angle NRO. This complete angle will get the sum of these two angles, this one and this one. And both the angles we have found, this is 30 degree and this one is 30 degree. So addition of it, sum of these two angles would be 30 degree plus 30 degree, that is total 60 degree. Third example, in this third example, they have said that RM and RN are the two tangent segments. So of course they are congruent. Prove that segment OR, this segment OR bisect the MRN. Bisect MRN, this angle they bisect it. Okay, and as well as MON. So MON. So here we should have the construction because MON angles are not given. So we'll have the construction first. So construction. So I'll draw segment OM and ON. So if I draw the segments OM and ON, then I'll get this angle. Now we have to prove that this OR segment, it bisects these two angles. What is the meaning of a bisect? Bisect means it makes the two equal parts. If I want to prove this OR is a bisector of this, means I have to prove these two angles are congruent. Similarly, I have to prove these two angles are congruent with each other. If I am successful to prove it that those two angles are congruent with each other, then of course MR would be the angle bisector of those particular angles. So we'll see the proof. To prove it, I'll see first, I had the construction MO, I have drawn it, and ON. So OM is perpendicular to MR. Same way ON is perpendicular to NR. Why they are perpendicular? By tangent theorem. So reason for them, that is tangent theorem. And for this I'll give 1. Now I'll consider the two triangles. In triangle OMR and triangle ONR, angle OMR is congruent with angle ONR. It is 90 degree, and therefore OMR and ONR are right angle triangles. Now we'll see the segment OM. Segment OM is congruent with segment ON. These are the radii of a semicircle. So reason for this, radii of semicircle. Similarly, this OR is a common side for both the triangles and it is a hypotenuse. So here hypo OR is congruent with hypo OR. Why? Because this is the common side. So common side. So by hypocyte test, these two triangles would be congruent with each other. Therefore, triangle OMR is congruent with triangle ONR by hypocyte test. And if these two triangles are congruent, therefore their corresponding angles would be congruent. So corresponding angles means angle MOR congruent with angle NOR. And these pairs of also these corresponding angles are also congruent. So OMRO and angle MRO is congruent with angle NRO. Reason: corresponding angles of congruent triangle, and therefore you can say that these segment OR bisect the angle MRN and angle as well as angle MON, and hence it is proved. In this fourth example, what is the distance between the two parallel tangents of a circle having radius 4.5 cm? So here I have drawn one circle which has the radius 4.5. So there are the two tangents which are parallel with each other. Suppose this is a tangent AB, and here if it is, this is the C is the point of contact. So similarly I will draw here, this is another tangent DE, and it has a contact, that means F. Circle, if I consider O, then they have said what is the distance between the two parallel tangents of a circle having radius. If you see here, if you join this OC and if you join this OF, so OC's distance is 4.5, OF distance would be 4.5, and this is the parallel lines, and if it is perpendicular, so you can get it C dash O dash F, that means they will lie on the same line, and if they lie on the same line, so the distance between these two parallel lines would be the sum of these two segments. Is it clear? So we'll see how to write. So here AB and DE are parallel tangents. OC is perpendicular to tangent AB. Similarly, OF is perpendicular to tangent DE. These two are perpendicular to with each other, and same way AB tangent is parallel with DE tangent. Suppose they are perpendicular, and if it is parallel, so here they lie in between on the same line. That means therefore we will get it C dash O dash F. O will lie in between C and F. And if O lie between C and F, in 9th standard we have studied the concept of a betweenness. By the betweenness, segment CO plus segment OF is equal to segment CF. CO distance is given 4.5 plus 4.5 is nothing but segment CF. So therefore segment CF is equal to 9.0, that means 9 centimeter. Therefore the distance between these two parallel lines is 9 centimeter. I hope you have understood the practice set 3.1. If you have any doubt or query, you can ask me in the comment box. Thank you.